Hello, welcome to problem 5.31 C and D, balancing equations. This problem comes from section 5.3, chemical reactions and equations in your textbook. And I'm also going to go to mastering at the end and show you how to input these answers into mastering. That seems to be a problem because you also have to include the phases as well. But first we're going to balance. So your book, and there's different ways you can go about balancing. Okay, so there's sometimes it's trial and error, sometimes it's really straightforward, but your book likes to tell you to begin with the formula that has the highest subscript values. Okay, and so that tends to work pretty good. Sometimes I will balance everything except for hydrogen and oxygen, and then balance hydrogen and then oxygen. So that's if you have those in your balanced equation, of course. But so we're going to look here. It looks like our highest subscript for our formulas between our two compounds here is going to be our first formula. Okay, so it's going to be this one here. Okay, so if we look, we've got one lead atom, and we also have one on the right side. So what you're trying to do is just basically balance the number of atoms. You have to have the same number on both sides. Okay, and like I said, it can be trial and error, and if you start getting numbers that are just really, really high, then you may have forgotten something. So I would just erase everything and start over. Okay. The key here also, why I picked this one, is because you have this polyatomic ion here, and so this 2 is going to be represented as saying that you have 2 of this total polyatomic ion. So you're going to have 2 nitrogens and you're going to have 6 oxygens. Okay, so this 2 is like it's multiplied times 1 and 3 times 2. So you have 2 nitrogens and 6 oxygens. So this is a common mistake as well. Okay, so if we look here, we have 1 lead atom, so 1 Pb on both sides. And now if we look at nitrogen, we have 2 nitrogens. Okay, so you have to recognize that first. And if we look over here, we only have 1. Okay, so the only thing we can do, we cannot change subscripts. We can only change coefficients. Those are the numbers out in front of our compound. Okay, so we have to put that 2 here. Okay, if you change the subscript, then you change the compound, and you can't do that. Okay. All right, so I mean, you can, but it wouldn't be correct. Okay, so now we've got a 2 in front of a 2 here because we need to balance our nitrogen. Okay, and so let's look at everything else. So we have 6 oxygens. Okay, now we have 2 times 3. Everybody see that? Okay, so we have 2 times 3, so we have 6 oxygens on both sides. Okay, so it looks like we've got 1. You can list them out if it helps you. We've got 2 nitrogen, 6 oxygen. Okay, so we'll check over here. We've got 1 lead so far. We've got 2 nitrogens, 6 oxygens. Okay, everything's looking pretty good so far. And then we get to our sodiums. Okay, so we've just got 1 here, but we have 2 on the product side. So we're going to need to have 2 here as well. So now we have 2 sodium and 2 chlorine. So if we go over to our product side, we have 2 sodium and we have 2 chlorine. Okay, so if we list it all out, looks like everything is balanced. Okay, and here in a few minutes we will go and I'll show you guys how to input these into mastering chemistry. Okay, D. This one gives students trouble because you kind of run into a little problem. Okay, so if we look here and we see that we have 1 aluminum on each side. Okay, and we have, let's see, we have 1 chlorine, but we have 3 on the right side. Okay, so we know we're going to have 3. Okay, so it's really easier to go ahead and balance everything but hydrogen and oxygen and then balance the hydrogen. So here we don't have oxygen, but if you did, Okay, so go ahead and balance our aluminum, then our chlorine. So if we look here, we've got 1 aluminum on both sides. We have now 3 hydrogens and 3 chlorines. We have 3 chlorine atoms, but we have 2 hydrogens. So this is our issue here. Okay, we have 3 hydrogens on one side, and we have 2 on the other. Okay, so what number can we put here that would make these equal each other? Okay, so this may be where you've run into and you've gotten stuck, because you can't think of anything that you could put here that would equal 3. Okay, so you have really 2 ways of doing this, but your book, I'm going to show you kind of the process and then show you which answer that your book on Mastering Chemistry is going to accept. But what you can do here is if you need 3, you're going to put a 3, let me erase this out of the way, 3 over 2. You have like a fraction here. So why you can do this is because it's like these 2's are canceling each other, and you're left with 3. Okay, because you're basically, obviously, 3 over 2 is like 1.5. So this is like saying 1.5 times 2, okay, because you have your 2 here. So 1.5 times 2 is 3. Okay, so the problem is you couldn't get a whole number that would work. Okay, so we have to use a fraction. Okay, but how your book accepts this is if you just go ahead and you double everything, then you get your nice whole numbers. Okay, so we're going to double everything. Okay, so we have this fraction, and some books and some chemistry teachers accept the fraction. Okay, but we're going to go ahead and double it. Okay, so if we double, we only have 1 aluminum, so we're going to have to double that here. Okay, and if we double our 3, we get 6. Okay, if we double, we just have 1, so we have to double it. Okay. Alright, so now if we take 3 over 2, or 1.5 times 2, so we double it, then we get 3H2. Okay, so now if you go back and check, we've got 2 aluminums on both sides, we have 6 chlorines on both sides, and we have 6 hydrogens on both sides as well. Okay, now I'm in Mastering, and I'm going to show you guys how to enter the correct answer into the blank here. Okay, it tells you to be sure to identify all of the phases in your answer. So this is a common mistake that students forget to do this. Okay, so if we look back, you should have your answer written out that we came up with earlier. So we're just going to input C just to be sure that you know how to do this. Okay, and so we have CB. Okay, and now we're going to have to go to this here. This is a subscript. Okay, so we have a script. Okay, then if you click way over here, so it's not wanting you to do it right beside, click over here, so click more farther to the right. Now you're out of your subscript mode. Okay, so we've got to put in our next parenthesis, and then we go to our subscript 2. So sometimes this can take a little trial and error to get all the details down here. Okay, and so now we're going to click way over here, and we're going to put our phase in, and we change to 2 moles of NaCl. Okay, now we go and get our reaction arrow. So as soon as you go here and you just click the reaction arrow, and it puts it there for you. Okay. And we have to go here to our subscript. There's your superscript if you need that. So go to our subscript, we're going to put a 2 there. We're going to click outside to get it out of subscript mode. And we have solid, and now we're going to have 2 NA, no 3. We need our subscript. And now we're going to click over to the side to get it out of the subscript mode, and we're going to put in our aqueous phase. And when submitted, it is correct. So just remember to go to your first button on the left here for subscripts. Okay, here's your reaction arrow. And then to get out of the subscript mode, the best thing to do is just to click further off to the right, okay, to get out of that mode, because that can be troublesome sometimes. All right, I hope this helps for problem 5.31. Thank you.